Hello, my name is Liam, and today I'm going to be showing you how to containerize and deploy applications using Docker. First of all, what is Docker? Docker is used for building, deploying, and sharing software inside of containerized applications. Containers are like virtual machines in the sense that they provide isolation from the host operating system while simultaneously avoiding the overhead of virtualizing hardware. But why use Docker over a virtual machine? And why would somebody choose to use Docker in their project? Docker provides many advantages over traditional virtual machines and environments. If you have ever had the issue of an application running fine on one computer, only to completely break when transferred to another, Docker may be a suitable solution for you. As mentioned earlier, Docker provides isolation from the host's operating system. This means that any pre-existing configs or packages that could interfere with any dependencies we wish to run our application with are separated via a Docker container. In other words, it ensures that some application running inside a Docker container runs the exact same way on every single machine, fixing the old "it works on my machine" problem. This also means that once the image is built, no configuration needs to be made to the hardware running the container. Simply download Docker, pull the image from Docker Hub or clone some repository, build the image, and run. There are three main steps to creating a containerized application using Docker: writing the Docker file, building the image, and running the container. Docker files are sort of the blueprint to writing a Docker image. They contain instructions on how to configure the environment to best run your application. As an example, I will go over line by line the Docker file I've used for my project. In the first line, I am pulling the base image that I'm going to use. This contains a base operating system along with any dependencies that I need to run my application. In my case, Python 3. In the second line, I am setting a working directory for the application to run in. The container's operating system will set this as its home directory. On line 5, I am installing both pip and the requirements specified by the requirements.txt file. This is analogous to installing requirements within a virtual environment, only it happens all at once. In the bottom left, you can see the requirements.txt file. This contains all modules and packages I wish to use within the container, as well as their versions. On the next line, I am running the unit tests that I have written for this service. This automatically runs every time the container is built, and is some form of continuous testing. Finally, on the last line, I am running the service itself. Using the cmd command specifies to the container that this is the main service that it will be running. Once the Docker file has been completed, the Docker image is ready to be built. This can be done using the docker build command. After running the docker build command, you should now be able to see the image on Docker desktop. You can choose to run the container from the GUI directly or use the docker run command to run it from the command line. I will now give a demonstration of all these steps in action. The first step is to navigate to the project's directory. In this directory, you can see the Docker file that I have written for this project. Next, I run the docker build command to build the image. You can see as the Docker daemon goes layer by layer, installing all necessary things to build the image. Finally, using the docker run command along with some other arguments that I will touch upon later, I run the container. Here, the container that was just built can be seen from the Docker desktop GUI. You may have noticed an extra argument that I passed into the docker run command. This is a local directory on my computer that I passed into the Docker container. Within this directory, there is an SQLite 3 database. I am using a feature called Docker volumes. Docker containers are stateless. This means that once they exit, no data is retained. This posed a challenge for me as one of the project requirements is a local database that stores persistent user data. This is where Docker volumes came into play, as they provide a way of mounting one of the directories of the host into the Docker container, allowing for persistent data to be stored. In other words, it allows for the Docker container to treat one of the host's directories as one of its own. To activate a Docker volume, you pass in the -v flag, along with a link to the host's directory, as well as where it will go in the Docker containers directory. An example can be seen in the presented slide. Thank you for taking the time to watch this presentation, and here is my references page.